Welcome to my channel. Let's talk physics. Accepted literature about space and space travel. Giving it a twist, let's talk about light. In physics, light travels at a specific velocity. It's massless and has a definite speed limit. Referring to Einstein's train and observations, we can refer the SP ace vacuum being void if interfering effects like inertia, mass, space is mostly empty and considered as to giving little to no gravity. Keeping this in mind, we have a train. This train represents the space fabric, as it's called in relativity theory. But space is expanding. Einstein didn't know this until 10 years after he published his work in physics. But our train represents the tracks light travels on while passing through space. Light follows the grid or fabric in its twists and turns, passing deep gravity wells that curve space. Light travels this course, so evidence shows light travels on the grid surface coupled to the grid. Physicists say that light cannot travel faster than its internal properties, which are protons. When light curves approaching gravity well, S hilly surface dense. It follows the curve, but it also blue shifts bending or red shifts expanding over the curves. By doing this, the train, which is expanding space, that travels faster than light. Physicists claim that light cannot change its definite speed, the speed of light. My argument is that the light signal is a passenger on the grid. Consider it as light is inside the expanse train, and yet physicists say it still stays at light speed. As a passenger, the light signal is in all actuality a passenger. It is a passenger. The train travels faster than light. The passengers in that train are in all actuality traveling faster than light. Their argument is that the light is stretched as it travels on the grid, that even though the light is coupled and follows the grid even inside the train, it is still only traveling at light speed. If light is a passenger in the train, it can vibrate all it wants. But physically, being in the train coupled to it, the light travels at the same speed as the train. This may seem like the train is a traveling ship traveling in space coupled to the grid, so acts as a messenger on the train, thus is not traveling faster than light does, but coupled to the grid. That's the surface of the space fabric. Without traveling itself as a carrier force, the light travels attached to the expanse surface faster than light. Physicists won't agree with this. Light is independent, so will not travel superluminal speeds, even coupled to something like our train that travels faster than it. The carrier force does not care who or what you are when coupled to it. The speed is measured by how much force or thrust, meaning light, is boosted through space. The carrier force does just that, carries the force applied to it, no matter what speed it is launched at. Keep in mind, protons gave a definite superposition that it takes time to calculate. That time has never been calculated to a single second. Secondly, thrust in space is the push. An item like light can be pushed. If that boost is greater than light speed, guess what? That's the speed space will abide by. Hope you like my video. All things in empty space can travel faster, having the boost to do so. Rodney Kowecki.
Or graviton particles act to direct light, allows to redirect light, also to increasing the light speed consultation. A research team led by David Norris, professor at the Optical Materials Engineering Laboratory at ETH Zurich, has now developed such pixels for the first time. These pixels can both steer light and analyze it, not only the intensity of the light, but also its oscillation phase and polarization can be controlled and analyzed. In the future, such bidirectional pixels could lead, for instance, to the development of camera displays that combine the two functions in a single device, patterns and images from overlapping light waves. The new results, which have recently been published in the journal Nature, are based on a fundamental physical effect, the so-called interference of light waves. When light is scattered by a surface, the waves originating from different points on the surface overlap. The shape of the surface determines the oscillation phases with which the waves propagate further. If the phases are equal, the light waves reinforce each other, but if they are opposed, the waves cancel out. Vectorial Fourier pixels for full light control and multiplexing. Norris and his collaborators used this effect to precisely control light with wave-shaped sculpted surfaces. They developed this processing method, which is precise to within a few nanometers, already a few years ago. For steering, the pixel, that is, the area on the chip where the material has been processed, first transforms the incoming light into a surface wave, a so-called surface plasmon polariton, propagating along the surface of the chip. At a different position within the pixel, the surface wave is scattered back out of the material as a light wave. Through interference of the light waves, patterns and images can be created. Using mathematical Fourier analysis, the researchers can calculate what these images will look like and what kind of surface pattern is needed for a specific image. Controlling phase and polarization. In addition to light intensity, meaning the bright and dark areas from which images are created, our Fourier pixels can also control other properties of the light waves, for example their polarization, says doctoral student Yannick Glauser. Polarization indicates the direction in which the electric field of the light wave oscillates. To generate light with an arbitrary polarization direction, they use surface waves with different polarizations, which overlap on the Fourier pixel. The polarization of the scattered light then depends on the surface shape of the pixel. The colored logo was created using the ETH researchers' new Fourier pixels. The letter E is roughly 1 millimeter tall on the camera. They can also precisely control the oscillation phase and thus, for instance, create light beams that have a hole in the middle, donut-shaped light beams, as it were. All of this even works with light of different wavelengths so that colored images can also be generated.